So this question is a diagram question. We know that because of the diagram provided here. We have a graph of y versus time, and then this diagram here of a circle. So the question says the figure on the left above shows a wheel with a mark on its rim. Okay, so we see the mark on the rim. The wheel is rolling on the ground at a constant rate along a level straight path from a starting point to an end point. So if I were to say this was the start and this was the end, we can start to see how this first picture here makes a lot of sense. It's rolling, to the right. Okay. And the question does say that it's moving at a constant rate, which I'm sure is important. The graph of y equals d of t on the right could represent which of the following as a function of time from when the wheel began to roll. So what's happening in this graph, y equals d of t? Well, it's starting up at a high point, and then it's going down to a low point, and then back up, right? So high, back down to 0, basically, and back up. So, over time, whatever it is that this graph is representing just kind of oscillates between 0 and some type of max value, and then right back down. So choice A says the speed at which the wheel is rolling. Well, if you remember, the question said that the wheel is moving at a constant rate, which means you would not expect the speed to go up and down because we'd expect it to be constant. Constant just really, if I were to graph it out over time, a constant speed would be a horizontal line. So choice A is gone. Choice B, the distance of the wheel from its starting point. Well, again, if this is the starting point, then over time, the distance from that starting point, right? So if I were to do a graph and say over time, to start off, the wheel is at the starting point. But as you go, right, it goes further and further and further away from the starting point until it gets to a stopping point. But again, that's not a up and down oscillating type of thing. It never comes back to the starting point and then leaves again. So B is gone. Choice C, the distance of the mark on the rim from the center of the wheel. Well, the mark on the rim to the center of the wheel, well, that's called the radius. The radius, or the distance between that mark and the center, the radius of a circle never changes, right? So it doesn't go, again, down to nothing and then back up to a maximum. So choice C is also gone. Lastly, we have choice D, the distance of the mark on the rim from the ground. Well, now that starts to make a lot of sense, right? Because even right here, let's erase a lot of this so we can see this clearly. At this point, where the point is, it's this far, right? A diameter distance away from the ground. But as the wheel turns, let's say the point will become here, and that's a little bit closer to the ground. And then eventually it'll be down actually on the ground, and then it'll start to make its way away from the ground again. So that one makes a lot of sense, right? Because that means that the high point here is when it's furthest from the ground, and the low point here is when that point is actually on the ground or touching the ground. So choice D is the best answer.